Let's have a look at exercise 6. Let's have a look at the law by Moore, or Moore's law. We talked about this doubling, which Gordon Moore first identified as something which happens every year, every 12 months, later every 18 months, and even later every 24 months. But it really doesn't matter if you talk about 12, 18 or 24 months. It is a doubling every certain period, which means in the end it's exponential growth, and that's something which is really a dramatic growth. Let's have a look. So what does it mean? So we talked about it. If we have a doubling every 12 months, 12 months, one doubling, or 1 year. Then we have every 10 years, 10 doublings. And in total, this is a factor of 2 by the power of 2 by the power of 10, which is equal to 1024, or roughly 1000. Which means we do have a factor 1000 when it comes to performance increase every 10 years if we have one doubling every 12 months. But how it is if we do have a doubling every 18 months or every 24 months? The question is simply, how often is 10 times a doubling within in what period of time? So let's have a look. 18 months, one doubling. So 180 months, which is equal to 15 years. We have 10 doublings, or the factor roughly 1000. And if we go for 24 months, one doubling, then 240 months or 20 years are required to do this factor 1000. And which key figures can we lay down for, let's say, if we talk about performance increase? We could talk about, for example, the memory size, the RAM, random access memory. A current PC roughly has 1 gigabyte, maybe 10 gigabyte, let's say 1 gigabyte. So if a computer now, that means in the year 2022, has 1 gigabyte, how much can we expect it to have in 2037, which is 15 years from 2022, if we have a doubling every 18th month? Then probably, the computer in 2037 will have 1000 gigabyte, which is roughly 1 terabyte. Same for the hard disk. Nowadays you have typically 1 terabyte. So in the future it will be 1000 terabyte. And I've forgotten if now the next one is petabyte or exabyte. But how is it with the speed of the computer? How can we measure this one? Here we have the term FLOP, or FLOPS, which stands for floating point operation per second. So the question is, how many of these very, very basic operations can a computer do per second? And just let's have a look at some figures. So here you can see a Wikipedia article about flops. And what is interesting in here is that you can see, for example, a modern computer can have in a peak time, Spitzenleistung, several hundred gigaflops, several hundred billion flops. Yeah, but looking at, for example, NVIDIA, a graphic processing card, if you have, for example, a gaming computer, then probably you will have an NVIDIA graphic accelerator. They have up to 19,000 gigaflops, which is roughly 20 teraflops. So it's really, really a big number. But once again, if we look into the figures given by Moore, in the year 2037, we will talk about 90,000 teraflops a computer can process per second. Really, really impressive increase of power.